Let's do part A. Here we determine the all zeros of the polynomial function f of x, which is given as f of x equals 36 minus x squared. So to determine the zeros of the function, we put f of x equals 0 and then solve for x. That is, we should set up f of x equals 0. So let's replace f of x equals 0 in this function and solve for x. So therefore we have 0 equals 36 minus x squared. Let me add x squared to both sides. When I do that, I get x squared equals 36. Now I take square root on both sides to solve for x. So square root of x squared is x, and square root of 36 is plus or minus 6. So which implies we get two zeros, that is x equal to 6 as well as x equal to negative 6. And so these are the two zeros of the polynomial function f of x, that is 6 and negative 6. Let's answer part B. Here we find the multiplicity of each zeros. From part A, we determine the zeros as negative 6 and positive 6. And we also determined that this negative 6 as a multiplicity of 1, and this positive 6, this is another 0, and the multiplicity of this 0 is also 1. So therefore we say that multiplicity of each 0 is 1. Let's answer part C. Here we have to determine the maximum possible turning points. Looking at this function, this is a quadratic function. So according to the definition of a quadratic function, it will exactly have only one turning point. Exactly one turning point. That is, the function will change its direction from increasing to decreasing or from decreasing to increasing. And in both cases, it will have exactly one turning point. So the answer to this question is one turning point. Let's do part D. Here we verify the answers which we obtained from parts A through part C. So in part A, we obtained the zeros of the function are 6 and negative 6. Here, this is the graph of the function f of x equals 36 minus x squared. I graph this using the graphing utility Desmos, and clearly we can see that this has two zeros, that is one at x equal to negative 6 and the other 0 at x equal to 6. So we verified the part A answer. Now let's verify the multiplicity, that is uh, from the graph of this function at x equal to negative 6, we see that it has a one multiplicity, that is the graph intersects, that is it crosses the x-axis at x equal to negative 6 as well as at x equal to 6, it crosses the x-axis. So we see that the multiplicity of both zeros are 1. So we verified the answer in part B, and we can also verify the part C answer, which is one turning point. We can clearly see from this graph of this function, the graph increases and then it becomes maximum and then decreases. So it changes its direction at x equal to 0, thereby reaching the maximum value. So it is basically turning at x equal to 0 just for once. Only at x equal to 0 we have a turning point. So we have verified the answer in part C, and we have verified all answers.